So the also we had done the 4 classes for the set, for the relations.
Excuse me.
Yeah, please ask.
Yeah, as in the Zoom link, it is written that this is the fifth class. What about the 4 classes?
Yes, those classes are recorded and we have I uploaded on the YouTube, so I can share the link with you guys.
Okay. Okay.
Okay, let's start quickly, guys, for the function. So very important thing, what is a function? So function is like in a general language as well, you know what is a function, right? So it's not like non-technical thing. So function is like a, you suppose if you do any work, let's give a very simple example. This is like a machine, okay? And if this is a machine and you give any input to this machine and that gives you an output for that input. So this machine works as a function. Okay, guys. So generally, like in a in a real life things, if I say you have, like what is a generator, right? What is a generator, right? So generator produce what? Electricity. Okay. But for that, what does generator need? Fuel, right? So if if there is an input as a fuel, so it generator gives you the electricity, right? So it does work as a function, right? Let me give you one more example, a simple example. This is a, data given to us. This is a bar graph. So it's like 0%, 0.5%, 1%, 1.5%, 2%, 2.5%, 3% like that. For the engineering, this is little greater than 2. This is engineering. Okay, for this is 1.5 for this is for physical science. This is for computer science. This is for liberal arts. This is for business. Okay, so this is a newspaper article actually. And the newspaper article is like how starting salaries for this year's college graduates have increased over those for last year graduates, right? So actually the language of this article is what? The salary increase in terms of the mathematical function, the salary increases is a function of the degree program. Right, guys? Right, so salary increase is what there? That is a function of a degree program, right? So this was the like in the real life example. Let's do an example there for the mathematical example. Okay, so if I give you a function, you can write down in terms of y is equal to fx, y is equal to gx, y is equal to hx, whatever, right? So here we have the two variables there. This is x and this is y. So x is what? X is a independent value and y is what? Dependent value. Right, guys? So if I give you a function, let's suppose gx is equal to x cube. This is a function gx is equal to x cube, right? So this expresses what? This expresses a functional relationship between a value for x and the corresponding value that results when the value of x is used, or you can say plug in the x cube, right? So suppose for x is equal to, I put the x is equal to 2. So what you get the value of the function, that is g2. G2 will be what? 2 cube there, right? So that is going to be 8. Okay. Same, you can plug in any value for x there. Suppose you plug in -1, so that is g of -1. That is going to be -1 cube, and ultimately this will be -1, right? I don't think anyone has the problem with the what will be the negative cube, negative number cube, and all these things. So these are the basic, right? Okay. So here, if you make the graph of this x cube, or if you can write it down, because you can make these points. So these points are like 2 and 8. This point is -1 and -1, and you can check for one more point. Suppose you take the x is equal to 1. So what will be that? G of g of 1, that is 1 cube, and is equal to 1. So the point is, another point is 1 and 1. So you can just, if you want to make the graph, so let me make a just a rough graph. This is not a proper graph. Gx, and this is x. So suppose -1 and 1 is here. 1 and 1 is here, and 2 and 8. For 2 and 8, it will be here. So definitely this graph will pass through origin, because if you plug in x is equal to 0, so y ultimately is 0, right? So this was like this. So this is the graph there, right? So this is the graph of this function, graph of g. Okay. Now let's understand the function from a mapping. So it's like just two things there. So this was the like degree program. Like I'm just giving the example from this only. So degree program, and this is salary increase by percent. Okay. So let's take a degree program of engineering, right? And let's take the degree program of the computer science. Here we do have like 2%, like 2.75 or 2.25%. Computer science is approximately 3%. Okay, so if you need to map this, so definitely you can say the computer science is like 3%, or engineering is 2.5%. So you can make a mapping like this for this. Okay, same this, the cube one, right? So if I make this as x and this is fx, so if x is equal to 1 to -1, and fx I write it down 1, 8, and -1. So this is fx is x cubed. So you can map this for this and for this. Right, guys? Is there any doubt? Is there any doubt, guys?
No, not yet.
Okay. So the thing is, how do you write down this? Suppose they can write it down like this in the set. So x and gx. So that means this is, they are talking about x and y only. Okay. And gx is just that x cube. Or if they simply write down gx is equal to x cube, so the both are same thing. Okay, guys. Now, the very important thing you need to understand, most of the students, they are confused with the domain, codomain, and range. Okay. Domain is very simple. Domain is all possible value for x, right? So all possible value for x is domain. Now, there's a little, confusion about the codomain and range, and most of the students, they really confuse about this. Okay, I'm just writing down all the definition there. So the first of all, the domain in a simple language,
Right?
what
ठीक है
can what can go into a function? Guys, please mute yourself. Is called domain. The second is codomain. That is what may possibly come out of a function is called the codomain. And the third one is very, the range. Range is actually what actually comes out of a function is called range. So when you see the, the basic difference between codomain and range. So in the definition only, what is the definition of the codomain? What may possibly come out of a function, right? And what is the definition of the range? What actually comes out of a function? That is range. Understand, guys? Let me give an example quickly. So you have the A, you have the B. So it's like 1, 2, 3, 4. And the B is like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is like this, this, and this. Correct, guys? Hello? Are you guys able to hear me?
He left the chat.
Yeah, I'm
Okay.
here again. I think there was some problem with the network. Right, okay.
Okay, no issues.
Okay. So on the B, there's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 is mapping with the 3, 2 is mapping with the 5, 3 is matching with the 4, 4 is mapping with the 6. Okay. So there, this is domain. What A belongs to 1, 2, 3, 4. This is domain. Now this entire is codomain. Right. So codomain is like 1 to 9. Now understand what is range. Range is actually this 3 to 6. So this is range. Right, guys? Understood?
Can you give another example?
Yeah, sure. You know. So again, if I write it down like A, B, this is 1, 7, 9, 10, and this is 6, 7, 8, 10, 15, 20. So 1 is suppose matching with 15, 8 is 10, 8 is 10, and the 7 is 7, right? So here domain is like all the elements here is a domain, right? 1, 7, 8, 10. Now codomain, all the elements here in set B is codomain. I mean 6, 7, 8, 10, 15, 20. But what about the range? So range is like 7, 8, 10, and 15. Understand, guys? Is there any doubt?
Please go ahead.
Okay. So how do we write down the terminology for the function? Right. Let S and T are the sets be sets. Right. So function, or you can say the mapping f from S to T is just like f S to T, is a subset of S multiplied by T, right? Where each member of S, remember, S appears exactly once as the first component of an ordered pair, right? Same like we did, like you can understand like this is S and this is T, okay? So each member of S, like you have the 1, 2, 3, 4, exactly once to the component of the ordered pair, like that, okay? So there S is a domain and T is codomain. Okay. So if you have S and T, the two element there, suppose you take the S, that's why I'm taking this small. So suppose this is S and this is T, right? Any element here. So if S and T, they belongs to the function, right? Then T is the image of S under F, and S is the pre-image of T under F. Okay, so this is the, you can say, the terminology for the function. Terminology for the function. Okay, everybody understand? So now I can relate, कुछ को नहीं अभी थोड़ा सा confusion लग रहा होगा, but for that please study the set theory, please study the relations, and थोड़ा बहुत जो extra पढ़ सकते हो from your 9th and 10th grade books, so please do that. ठीक है, वो बहुत जरूरी है, एक बार रिवीजन होना थोड़ा सा जरूरी है, बिकॉज ये थोड़ा सा उससे हायर लेवल है. ओके. Okay, now understand which one is a function and which one is not a function. Okay, are you able to see on the screen?
Yes.
So we'll study about one function after this. The first one is this is a proper function because there's like one element of the x is, they are mapping with the one element of the y. So in this case, because the range is what all the mapped elements. So all the mapped element is like A, B, C, D here, and that is as same as the codomain. So in this case, range is as same as the codomain, right? In the second case, this one is the domain. This one is the codomain for sure, and this one is also function because the every single element from the domain is mapping with the codomain elements, right? Uh, this one is also a function like again, but in this case, the second case actually range is different than the codomain, like we discussed earlier, right? In this case, what is given to us? This is x and this is y. Again, 1, 2, 3. This is also a function, right? For the x, 2 and 3, they are mapping the same value of y, right? Okay, and so this is not a function. This is not a function. Why? Why? Because for one value of x, they are getting the two value of y there. Like for 9, we are getting the two value of the function that is 3 and that is 3. 3 and 3, whatever, minus 3 and whatever. So same here, like for we are getting the two values for the, so we are getting the two values. I think this was positive and negative, all of these values, right? So whenever you get the two values for the value of x, whenever you get two values for one value of x, so that is not a function. That is not a function. Always remember, that is not a function. Okay, let me give you one more example through the mapping. So you have the A and B. You have 1, 2, 3, 4. B is 6, 7, 8, 9, 10, and whatever, right? So for one, you are getting the two, uh, values 7 and 9. So that means this is not a function. This is not a function. Right, guys? I hope you understood. So what is a function? What is not a function?
Yes.
Okay. Second, I mean, the last one, this is also very important. So this is also not a function. Why this is not a function? Because if you see there, 2 is mapped with the T, 5 is mapped with the F, 9 is mapped with the N, but 7 is left out, right? So none of the element from the domain should be left out. If there is any left out element, so that is not a function. Not a function if there is any left out element in the domain. Let me give you one more example. So you have this one and this one. So like A, B. So it's like 4, 5, 7, 9, 10. And you have A, B, C, D, E, F. Okay. And this is you are mapping like this, this, and this. But in this case, 9 is left out. So that means this mapping is not for the function. Right, guys? Hope you understood. Okay. Now next is okay. I'm just putting some example there. You need to find the using the domain and codomain. You need to tell if they are the function or not. So the first one is f is such that s t where s is equal to t 1, 2, 3, and the function is 1 and 1, 2 and 3, 3 and 1, 2 and 1. So we need to tell is this a function, this is a function or not. Okay, so how to do? So when you see there, you make the two S and T. This is 1, 2, 3. This is as well 1, 2, 3. Correct, guys? So what is the first case? First function 1 is mapping with the 1. Okay, we did this. Second case 2 is mapping with the 3. Third case 3 is mapping with the 1. That can work. But in the fourth case 2 is mapping with the 1. That is not possible. Right? Like we discussed, like the 1, like x should not be match with the two y values there or the another so that means this is not a function. Understand this, guys?
Yes, yes.
Any doubt here? You can ask me if there is any doubt. Okay, there can be a question type of this type. So you have the function z belongs to c and be defined by fx is equal to x square. So the question is, what is the image? The image of -4. Second is, what is the pre-image of 9? Okay. So function we know that is x square. Okay. So what we need to find? We need to find what is the image of 4. So what will be the 4? When you plug in x is equal to 4 there. So what will be the image of that? 16. Okay. In the second case, the question is asking what is the pre-image of 9. Suppose 9 is here. So what will be the pre-image of that? So you can say x square is
3.
equal to 9, positive or -3. Right, guys? Any doubt? Okay. Now the 2, 3 important point. So that we call the one-to-one function and all that. So that we write down as the properties of the function. Okay, so I give the one case like this and this. Yeah, 1, 2, 3, 4. Yeah, 5, 6, 7, 8. They are mapping like this. Okay, so in this case, what do you see there? You see here the codomain is as same as the range, right? So this function we called at onto function. This function we called at onto function, where codomain is as same as the range, right? So in the definition, I can write down if the range coincides with codomain, then function is called an onto function. Or we also call this surjective function. This is also very important, surjective function. Right. So if I say you have a g function r to r and g of x is equal to x cube, right? So definitely this is a onto function, right? Because there are only the real values you are taking. So suppose you need to plug in any value there. So suppose x is equal to 1. So you get the gx is equal to 1 only, and x is equal to suppose 2. So you get the gx is equal to 8, right? So every real value here, suppose you take the 1, 2, 3, you map with the 1, 1, 8, and 27. So you map with the all elements of the codomain, and that's the same thing as the range. So definitely that is a onto function, or what do we call that? Surjective. Right, guys? Is there any doubt till here? Okay, cool. So the second is this we call the one-to-one function. Or we also call that injective function. Okay, so it's like no member of T is the image under F of two distinct element of S. Right? So like if I say g of x is equal to x cube, this is one-to-one function, because if you plug in the value of x there, suppose 1, 2, 3, whatever, you'll get the one value of gx. It can be something like 2, whatever, the 1, 8, and you can say 27, right? But if I talk about the x, or you can say hx is equal to x square, right? So in this case, if you plug in 2, so that will also give you 4. If you plug in -2, that will also give you what? 4, right? So in this case, when this is 2 or -2, it will give you 4. So this is not one-to-one. This is not one-to-one function. Okay. Okay. So right. So this function we call the injective function, right? So all of the the function that is one-to-one, we call those as a injective function, right? Right. So we call that as the injective function. Okay. Now this is also important. That is bijective function. So bijective function, if a function is both injective and surjective, is both injective and surjective, then it is called a bijective function. Okay, guys. So like if a function is 1, 1 to 1 on 2, so that we call the bijective function. Now, this is very important. Actually, you will get a question like this in the, you may get a question like this in the exam. So first one is like, you need to finding the domain and the range. Now, how to find the domain and the range of a, suppose if I give you under root of x minus 5, right? If we need to find the domain or the range of under root of x minus 5. So domain means we discussed earlier all the values of, x. So what is all the possible value for x here? Can you tell me, guys? What is all the possible value of x there? Okay, suppose if I write down like just under root of x. So what is all the possible value for x there? What is the possible value for x there? So what cannot
Natural
be?
numbers.
Actually, x can be greater than equal to 0. It can be 0 because under root of 0 is 0. That's fine. But x cannot be negative. Suppose if I say under root of -1, what does that mean? Under root of -1, so it is imaginary value, right? Or you can say the iota. So that doesn't make sense, right? So that means whatever there under the root, so that should be what? Greater than equal to 0. So that means x should be greater than equal to 5. Correct? Right, guys? So anything, and what will
Yes.
be, yeah, what will be the range there? What can be the value of y there? Value of y can be what? Because y can be 0, but not less than that. So y can be what? Greater than equal to 0, correct? Is it possible the value of y can be negative? Is it possible the value of y can be negative there? No, right? So definitely the y is what? Understand, guys? Greater than equal to 0 or the real values, right? What about the domain? If I give you this, another one, fx is equal to 1 plus 4x divided by 2x minus 1. I give this, right? So what is the domain there? Is there any restrictions there? Yes, restriction is there. And what is that? Because when you do the any of the fraction, if the denominator is what? 0. So that makes it undefined. That makes it undefined, right, guys? So definitely the denominator, that is 2x minus 1, cannot be equal to what? 0, right? That means x what? Cannot be equal to half. Other than that, everything is fine, all real value, right? So you can say x belongs to real number, but x cannot be equal to 2. You can write down like this, domain. Or if you want to write down into the notation, so it's like negative infinity to interval notation is half union half to infinity. Right, guys? Any doubt for the domain here? Because any other fraction, the denominator cannot be 0. If the denominator cannot be 0, so for that value, that will be the undefined, right? So we need to skip that value from the domain. Is there any doubt, guys?
No.
Can you quickly, all of you can quickly find the domain of x plus 1 divided by 2 minus x. And find the domain of 7 minus x, under root of 7 minus x. Okay, so in the first one, you have x plus 1 and divide by, again you have the fraction. So 2x minus 1 cannot be equal to 0. That means x cannot be equal to 2, guys, right? So anything other than the 2 is only a number will be the answer for this, right? So you can write down as the notation of negative infinity, the interval notation to 2, union 2 to positive infinity, right, guys? Second one is you have under root of 7 minus x is what greater than equal to, this you need to find domain of this. So that means 7 minus x should be greater than equal to 0, right? That means negative x is greater than equal to negative 7. Okay, after this there is a catch. So if you ever studied about the, the inequality, so because this is negative x here, so you need to find the inequality for x. So you need to what? Divide it by, you can say, negative 1. So if you divide or multiply any inequality with a negative number, then sign flipped. Then sign flipped, right? That means this sign will be flipped. So what you get now? X is what? Less than equal to 7, right? That means negative infinity to 7, but at this time this will be bold because this is equal to as well. So this will be the interval notation. Right, guys? So this is all. Although we have left it the little bit, that's we'll do in the next class. Okay, and in the next class we'll also start the coordinates. Right, guys? I'll send you some question for the practice as well. I think you must have received the assignment as well, so you can try those assignment. Before that, you can watch all the videos through the the IITM portal जो आपको मिला हुआ है पोर्टल, तो वहाँ पे आईआईटी मद्रास के जो प्रोफेसर्स हैं उन्होंने वीडियोस डाली हुई रिकॉर्डिंग के, तो वो आप देख सकते हो। जो मैंने कुछ वीडियोस बनाई हैं जो यूट्यूब पे है वो भी आप देख सकते हो, ठीक है? तो और फिर उससे उसके अकॉर्डिंग आप क्वेश्चंस सॉल्व करना स्टार्ट करो, प्रैक्टिस करना स्टार्ट करो, ठीक है? कुछ डाउट आता है तो यू कैन आस्क मी ऑन द ग्रुप एज वेल, राइट? कैसे भी करके, ठीक है गाइस? चलो लेट्स सी, मिलते हैं टुमारो डे आफ्टर, राइट? Okay guys, bye bye.
Thank you, sir.
Bye, take care.